Hallo, ich bin Frédéric. Ich komme aus Kanada. Ich spreche Französisch und Englisch. Ich lerne Deutsch. Ich bin ein Anfänger. And that's where I switched to English, so sorry about that. I hope next time I will be able to speak a bit more German. All right, so thank you so much for being here. I'm Frédéric Desbiens. I'm the program manager for Edge Computing and IoT at the Eclipse Foundation. And today, we'll try to make sense of Eclipse IoT together. Okay, so there will be an exam. Everything you need to know is on, the whiteboard here. So please take notes. I will be asking questions at the end. All right, good. So the first time I did this talk, it was funny because I had no slides and no idea of what I was talking about. And this was a few months back. So today I've got slides. I still have no idea. So we'll see how it goes. All right. So first, Eclipse IoT. Let's take a step back. We're talking about the Internet of Things. And we keep saying IoT, 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 and keep maybe forgetting what this is about. So just to make sure we're on the same page. So, Internet of Things, and here I'm a non-native English speaker, right? So I will botch the word, I will say things probably several times. Please forgive me. Internet of Things, so what's a thing? Well, a thing is essentially a physical object that can do two things. Gather data and send it somewhere, and then receive orders and act. That's literally all there is to it, and it can be any physical object. A red hat like that, my glasses, your car, your phone. Your phone is a particularly good example of a thing, okay? And now, for the internet part, what are we talking about here? In IoT, there is always a network connection somewhere. However, it's not reliable, you shouldn't count on it, and it's not stable. And you have to design around this. It's really important, okay? If you think, okay, I will put those sensors all over the place in the city, and the network will always be there and it will always work as expected, you will have a big failure. So it's important to remember that. And IoT is not just about plugging something on the public internet. Okay, you can do things in a secure way on a private network. Okay, it's really not just about public internet. It's important to remember that. All right. Now, when we think about a thing, okay, those things are defined by constraints, essentially. When you work with that, you have to take into account the power they will consume. If you put sensors in the walls of this building to make it a digital building, maybe those sensors will be there operating on battery power for 10 years or more, okay? So you have to pick the hardware that goes with that kind of use case. And then bandwidth, especially if you work with advanced usages like video and stuff like that, you need to keep an eye on that because obviously bandwidth is two things. It's expensive, and once again, it requires power. The more bandwidth you use, the more power you consume. And then obviously compute. Most things have cheap processors, okay, low performance. I mean, one of the boards I have has a 64 megahertz processor. I haven't been using that for, since I had hair on my head, so you can imagine how long it's been, okay? And then environmental, temperature, pressure, everything you can imagine in nature, so to speak. Most of the time, you will have to take that into account, especially if you work outdoors. So those are things you have to remember. It has nothing to do with Eclipse IoT per se, right? Just that when you design an IoT solutions, those are things that you need to take into account. All right. So if we think about what's in the Eclipse IoT toolkit to work with things, okay, we've got quite a few projects there. First are EMRA and UPM, and those can work on Linux or on the Zephyr RTOS from the Linux Foundation. Okay, which is a good choice in that space because it's vendor neutral, it's well supported, it's got a long-term support branch, etc. Anyway, EMRA and UPM. So they are abstraction layers that enable you to take your constrained device or your thing code in C, C++ and make it portable from one processor or one set of sensors to another. It's really essential because you are making, if you are designing things, okay, and selling them to the market, well, maybe you will sell them for 5 or 10 years. But 2 months from now, your supplier will discontinue the CPU you are using. So you have to use an abstraction layer to make things, so to speak, easier. And then manage and update those devices. Okay, we've got several projects there. Leshen, Hogbit from Bosch, and Sentinel, which is a newly announced project that will be a Hogbit client for various platforms. Kapua, Wakama, all of those projects cover your angles to manage and update those devices in a variety of ways. So some of them, like Kapua, are really a centralized system running on the cloud in Java. And then Wakama is a C client you integrate to your code. So there are variations there. Unfortunately, I just have 30 minutes. But those are the main names that you will look at. And especially Hogbit is run at scale on the Bosch IoT cloud. So that's a proven solution for, if you have a few million devices. And then on the development side, we've got an upcoming project. The proposal has been made public right now. So embedded C, C++ development tools. So very easy to use set of plugins that you can retrieve under a different name on the Eclipse marketplace right now, on the top of the C development tools or CDT. And then it will install for you everything you need to work with the embedded ARM and RISC-V GCC compilers, okay? So this shows a bit of the variety we have, and we have other projects that I don't have the time to mention here. By the way, if you are a committer or working on a project and I don't name your project, please forgive me, it's just that we've got time constraints. So, MRAN, UPM, Leshen, Hogbit, Kapua, Wakama, embedded. Okay, good. Now, well, when you think about IoT, there's the cloud. I mean, the cloud's everywhere. The cloud's anybody's answer to any question nowadays. The thing with the cloud, what's the cloud? It's not a specific location, because you can have the cloud in your own data center. The cloud is a mindset. Repeat after me, close your eyes. The cloud is a mindset. This is about on-demand resources, essentially. The fact that you can, in a standard way, ask for compute resources, storage, in a way that's transparent to the person deploying the application, and use them. And the same goes for networking and other types of resources that you can use to define an application or even a full environment. The important thing is no direct active management. So the principle behind the cloud is that devs don't have to manage servers. And, well, devs, not devs. That's about DevOps as well. The fact that most developers will play the role of operator as well in the cloud, which wasn't the case previously, where you have clearly defined differences between operators and developers. So the cloud is anywhere and everywhere. You can have public cloud, you can have private, you can have hybrid, you can have whatever. Really, it's a mindset. It's a way of doing things, and there are many, many ways, obviously, to implement that. So in an IoT perspective, what do we have on the cloud side as components that you can deploy to implement solutions? Well, first, we've got a set of brokers and servers. So Californium implementing the CoAP protocol is a popular server, as well as Mosquito as an MQTT broker. And then we've got Hono. Hono is really important because this is about message routing. The worst mistake you could make if you are building an IoT solution is to tightly couple your things to a specific software backend. Okay, why? Because today your boss asks you, okay, take the sensor data, put that in the ERP. Okay, done, boss. Okay, now we have 10 other applications that need that data. Oops. So Hono is very good at that, publishing and subscribing to that data and pushing that to the right places. And then analytics. So we've got an upcoming project there called Streamsheet, sorry. So Streamsheets is about, spreadsheets in the cloud, but the data source is in real time, data from your MQTT broker or whatever you have on the back end, using IoT protocols, and then you write little formulas and you see graphs move in real time. It's really impressive. And it's very cool. It's a German company that just joined the Eclipse Foundation, so expect that in our ecosystem very soon. Very cool project. All right, so a few more names to strike. Okay, things and the cloud. Isn't it beautiful? You have all those connected objects and everything works out of the box every single time, isn't it? Or not? Okay. Yeah, there's a bit of a problem here. And the first of those problems is the distance. I mean, the cloud, as I said, can be anywhere or everywhere, which means that when my data, starts, leaves those sensors, leaves those things, and is sent to the cloud, you don't know how long it will take before it reaches the cloud. It can be very, very, very slow, and then we are using protocols that put all the packets in reverse order or out of order and reassemble things. And that's why when you have a Zoom call with me and I'm at the office, sometimes, it's painful because packets have been dropped, okay? But in fact, there are more problems than that, and that's what I call the 4 horsemen of the cloud apocalypse. But that's the next slide. So what do we have on the component side to link the things with the cloud? A variety of protocols. So CoAP Californium is both a server and a client, okay, written in Java. DDS, we got Cyclone DDS. MQTT, we've got the PAO clients. OPC UA, we've got Milo. PPMP, we've got UNID. All of those things here, okay, have different, sometimes implementations in various languages. And, if you're asking me which one is the right for my project, I don't know. I need to sit with you and talk at least half an hour to figure out what's your use case and what you're trying to do. But the great thing is, whatever protocol you actually need, we probably have an implementation for it, okay? And that's what's fantastic about Eclipse IoT. So, PAHO, Milo, UNID, Cyclone, that's good, making progress. And yeah, not everything is always easy. So yeah, the 4 horsemen of cloud apocalypse. The big problem that I just described previously about linking the things directly to the cloud is latency. The fact that it's not predictable the time, for you to get the data from the things when you are on the cloud. But there's also the bandwidth problem, okay? Especially if you work with video or stuff like that, you don't want to stream video 24/7 of something when all you need is images, let's say, of an intruder in your building. You don't want to stream the video always, just when there's an intruder. So you have to design around that. And then the sampling rate. The sensors that you can get, they will happily for you retrieve 1,000 value per second. You don't want to stream that in real time to the cloud. You don't. Because what you want is, am I in the correct zone, in the correct threshold for operation or not? So what you want to send to the cloud are just regular reports, let's say every minute or every 10 minutes, depending on your use case, or maybe just the exceptions. And then you start streaming real time because temperature is growing and this will explode, so please do something, okay? So this is an important consideration as well. And finally, there's cost. The more data you transmit, the more expensive your solution will be. So you need to take that into account when you design things. And that's why you need something in the middle. Something's missing there. And that thing, so to speak, it's not a thing like the other. Yeah, I'm using the word thing way too much. All right. So what's missing in the middle is edge. And you will ask me, where's the edge? Is there a single edge, multiple edges? Well, there's a thing. There are as many edges as you have use cases or sites. Especially if you are in manufacturing, think about a smart factory with robots and stuff like that. You have what we call the operating technology edge. Traditionally, the people running those robots in factories and all of that, they were completely separate from IT with their own little solutions and all of that. And now IT wants to invade a bit that field, and then you have people, butting heads together and fighting. Okay, you don't want that. So edge is a good way to manage those kind of challenges, obviously. So there's an IT edge, there's an OT edge, whatever. But this is a very important pattern, okay? And we've got quite a few projects in that space as well. A more well-known project that we have, because it has existed for a few years already, is Cura. So Cura is a solution written in Java OSGI for gateways. And then we've got emerging projects like FogOS and IOFog, and essentially they each have their own take about how to make the edge happen, with IOFog being more oriented on container orchestration and defining microservices that you plug together in this edge compute network. And FogOS is rather, okay, let's make one big compute fabric with my servers, my things, my edge nodes, and all of that, and we'll schedule something on those nodes eventually in some way, okay? So slightly different approaches, but complementary at the same time, and it's really exciting. So we are working now on launching our edge working group with those 2 projects as the initial ones, and you can expect many more innovations in that space from the foundation. All right, so IOFog, FogOS. Okay, so it's pretty good. I mean, we've got things, we've got the cloud, we've got edge, all of that is good. And every component that I talked about up to now is a kind of a building block, something that you as a developer can leverage in order to build an IoT solution. But we've got what I would call more vertical solutions or vertical products, or call them whatever you want, in our toolkit that you can leverage to deliver specific functionality as well. ForDiac is a good example. ForDiac is an IDE built on the Eclipse IDE and a runtime that you use to run programmable logic controllers. In other words, controllers that will control machines in a factory. So, it doesn't fit anywhere else because it's its own little vertically integrated solution, but obviously it's using Eclipse IoT components like Milo and that kind of stuff under the hood. Then you have something like Keeple. Keeple is an open standard about contactless payments. So you can use that. It's already in use in France, in Paris. When you pay for the bus using a card in Paris, you are using Keeple technology. And I know that the French equivalent of the Deutsche Bahn, SNCF, is using it as well in some train stations and that kind of stuff. But you could use it to implement security for the doors in your own building. The way Keeple works is essentially it works with cards with encryption and then can manage authentication simply. So it's really nice. Then you have Cuxa, so brand new project there about the connected vehicle. And we've got a whole set of automotive working groups working with the automakers and that kind of stuff. But this one is a bit closer to IoT use cases. That's why it's living in our working group. And finally, we have Voltron. Okay, Voltron is about energy management. So this comes from the US government. So they contributed this to the Eclipse Foundation. And it's deployed in various campuses, corporate campuses across the US, for example. And you can run Voltron on Linux nodes, very, very small ones or very large ones, because it's a multi-node environment and it's very, very flexible. But this is all about energy management. And remember, at the very start of this presentation, I told you power is certainly a very important constraint for IoT projects. So you may want to have a look at Voltron to complement your solution and measure energy consumption in what you deploy. So, ForDiac, Keeple, Cuxa, Voltron, we covered everything. Well, mostly everything. There's Project U. What's Project U? It's you. You are my project, in the sense that the whole point of this presentation is to give you a taste of what we have in our ecosystem, in our toolkit. So please, if you are thinking about building IoT solutions, reach out. Reach out not only to me, but to the other members of our community to figure out what's the right mix of components of Eclipse IoT projects for my solution. Please ask. We're there to help. Not only that, but once you have started using them, please start contributing. This is where you will realize the most benefits. Why is that? Well, suppose you have a problem with Ono, and you're using this in production. There's a bug. You need a fix fast. Do you think this gentleman here, Kai, will answer you Sunday at 11:50 before going to bed. Well, he will do that if he knows you, if you're part of the community. If you are a random stranger, I'm quite sure he won't be as amenable. Although, I mean, you are good-mannered and everything, right? Yeah. All of that to say, it's much faster and easier to get support from an open source community when you are part of it. And it is much faster to get support from an open source community than to go to a commercial software vendor, because they will put you, they will read your contract. Oh, you are, you have signed this level of support, so you are owed an answer in 2 days from now. So we put the intern on your file because we have nobody else. He doesn't know about anything, and you have an answer and a patch maybe 3 months after. We all went through that. I mean, I exaggerate a bit, but let's say that there is a level of dynamism in an open source community that you don't get in commercial software. So please take advantage of that, which isn't to say that our commercial partners that sell stuff built with Eclipse IoT don't offer good support. Please, they offer good support, but things are always faster on the open source side of things if you know the right people. And the right way to know those people is obviously to be part of the community. All right. So this is another representation simply of what I just said. Not everything is on the diagram, but those are various IoT concerns. And for reference, I put the little logos and all of that of the various projects I just described. Some of them that I covered in earlier slides are not there because they don't have logos yet or that kind of stuff, so it's a bit complicated. But still, all in, if you consider this slide deck, you have at least a good starting point, a good starting kit to try to figure out how to piece Eclipse IoT components together. Okay, so now my call to action. You go to ioteclipse.org/projects and have a look at what we have, because there are some projects I didn't cover. Please try them. Everything is open source, okay? So no fee, no obligation, nothing. Subscribe to our newsletter, follow us on Twitter, and participate to our virtual IoT meetup. And we'll have an IoT day in Grenoble on February 13. More details to come, but that's already on the calendar. I will be also at Bosch Connected Experience, Bosch Connected World in February in Berlin. Looking forward to that. Ich liebe Deutschland. And yeah, we'll see for the rest. Oh yeah, absolutely, right. I wasn't even with the foundation on February 13th, so yeah, good catch. Thank you so much. I will correct this on the version of the slides. So we are mostly done, but I'm more than happy to fill the time that rests with a few questions if you have any. Was I that clear? It's impossible. All right, so thank you very much for attending this session. I hope you have fun during the conference, and we have regular calls of the IoT working group every 2 weeks. So you can join if you wish to hear about what's happening in our community. This is wide open, so please come see me and I will tell you how to get the invite on your calendar. Thank you very much and have a fantastic EclipseCon.